All right, my video I don't know, I goofed up my video. I don't have, I missed a couple slides in there, so I wanted to finish those up for you. So let's go back to the slide where it was talking about how power functions can look differently. So you had on your notes some that you were supposed to figure out what they look like. Let's see if you did that or if you can figure it out. Remember, just to recap, that a power function can be a lot of things. If it were to look like a power of 1, then it's just linear. But as that power gets larger than 1, it starts to look more like a parabola or a cubic or something like that. If it is less than 1, it starts to look like a fraction, like a 1/2 or a square root. So it would do this. And then the last thing it could do is if it were negative, it would actually start to look like a rational. So it would go like approach the x-axis. Now, as soon as I change my a value that's in front, or my k value, I guess it is in this example, that leading coefficient, if that's negative, there will be a reflection going on. Okay, so on your homework, what you're going to have to do is I'm going to give you just like the right half of the graph. So it might be like on this one, it's a cubic. I know what a cubic looks like. It gets bigger than 1, so it should be growing upward here. It's growing upward. Oh, but wait, the a value is negative, which means it would reflect. So then the answer you should have had was something like this, that it goes downward. Okay, this next one. Again, only looking at the right half, like your homework is going to be. This is x to the 1/3. Okay, it's not a square root, but it's actually a cube root. It's less than 1, so then it's going to start to shift off to the right like a square root function. Because the 4 is positive, it stays up top. And this last one, this is a negative, so a negative exponent looks like a rational. So it looks something like this. Since your a value here, I keep saying a value. I know up here it looks like a k value. I think a lot of times, like on your calculator, they'll show it like this. A times x to the b power. This is kind of what your calculator, when you run a regression and stuff. So this leading coefficient is your constant, which is why we had a k up there earlier. Anyhow, so since this leading coefficient is positive, then it does stay up in that top quadrant. All right, the other slide that I skipped is a very important slide. This is going to be on your test. This is how to write power functions. Now, we have already written quadratic functions. We've written linear functions. All right, now we're going to write a power function. Now, this looks like y equals kx to the a. I might shift this just because I want it to start being familiar to you from your calculator. So I'm going to write that differently. The idea is the same. Actually, I might even make this a y for you because it will look like that on your calculator. So let's change that to a y equals, and then there's a leading coefficient. Your calculator will call it a. X raised to some power is a b. So ultimately, regardless of which format you use, you're looking for the leading coefficient and you're looking for the exponent. Those are the unknowns to write this function. All right, to do that, you're going to plug in an x and a y. Now, I have lots of options. I've given you more than what you need, but what I will always give you is the scenario where the x is a 1. Let me show you why. If I plug in that ordered pair for x and y, I'd put a 2 here equals a times 1 raised to some power. Now, this is somewhat unfortunate because I have 2 unknowns I'm looking for here. I'd be looking for the a and I'd be looking for the b. It's hard to solve for both of those, except that because I have a 1 here raised to a b power, think about that. If it's a 1 squared, you'd still have 1. If it was a 1 cubed, it would be a 1. 1 to the 4th, 1 to the 1/2 is still 1. So it doesn't really matter what the b value is here. That term is always going to simplify to a 1, which then must mean a is equal to 2. And that's important because I just found one of the unknowns for writing my power function. Once I have that, I can start over. So now I'm going to go back and I'm going to rewrite this right here, but I'm going to fill in what I just learned. I just learned that a is 2. X raised to some power. So now I'm going to work on finding that power, that b. So I just pick another point. It doesn't matter. Well, I wouldn't pick the negative one either, because that might present an issue. Let's just go to a 216. Let's plug that in. So 16 is the y, 2 and 2 is the x. And then to solve this, I can't multiply those 2's because the first 2 is not being raised to the power. So I would instead divide and move it over to the other side. And actually, to solve for b here, you would be doing a logarithm. That's how you solve for an exponent. But we have not yet reviewed logarithms. We will in our next chapter. So I'm going to give you some here that you can figure out in your head. You can just look at that and know, oh, 2 cubed is 8, so b is going to have to equal 3. All right, you've got your 2 unknowns. So then your last job is to go ahead and write that power function. Y equals, the leading coefficient is going to be a 2. X is going to be raised to the third power. And you could always test any of these other ordered pairs. If you plugged 3 in for x, let's see what would happen. That would be 3 cubed, that's 27, times 2 is, yep, 54. It works. All right, there's your power function. All right, so you have a couple of these on your worksheet to do. Again, I will always give you this scenario where the x is equal to 1. That's how you start to go figure out the a. Then use one of the other points to go find your b. All right, good luck.